Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Chui Mingjun. Today we will study Chapter 3, PLC Program-Controlled Punching on the Training Bench, Design of State Diagrams and Sequential Function Charts. In this lesson, you will master the methods for designing state diagrams and sequential function charts, clearly understand their applications in PLC-controlled punching systems, comprehend the transition logic between various states and the corresponding step functions, and ultimately be able to independently draw basic related diagrams and write corresponding programs. In this punching system of the training bench, the entire operation process is divided into several states. Specifically, it includes the initial power-on state, followed in sequence by the run state where the main motor starts, the stop state, the reset state, the pause state, and the subprogram reset state, totaling 5 states. When the system meets a specific condition, it transitions from the current state to the corresponding next state. At the same time, the action being executed in the previous state comes to an end. To represent these states clearly in the PLC program, we use 5-bit memory units to correspond to the 5 main control steps, namely M0.0 to M0.5. Among them, M0.0 represents the automatic start step. When this bit is set, it means the system is in the automatic start state and ready to begin the subsequent punching tasks. M0.1 corresponds to the stop step. Once it is activated, the entire punching process will come to a halt. M0.2 is the reset step, used to restore the system to its initial state. M0.4 represents the main program pause step, which allows the punching process to be temporarily paused without completely stopping, making it easier to resume afterward. M0.5 is the subprogram reset step, specifically used to reset parts related to the subprogram. However, apart from these 5 main control state bits, the automatic punching process also involves a series of more detailed steps. We have used a total of 27-bit memory units, from M5.0 to M7.7 and M8.0, to represent the 27 steps of the automatic punching process. Next, let's look in detail at the specific operation of each step. First, M5.0 represents the punching preparation stage, during which the cylinder extends and clamps the workpiece securely in place to prepare for the punching operation. Next, when the system reaches the step M5.1, it indicates that it has reached the position for the first hole, as if telling the system its target location. Then, M5.2 is the step that signals the execution of punching the first hole. At this point, the punching mechanism activates and completes the first punch. Continuing in this manner, M5.3 indicates the system has reached the second hole position. M5.4 signals punching the second hole. M5.5 corresponds to the third hole position. M5.6 signals punching the third hole. After completing the punching of the third hole, the system proceeds to tool change. At this point, M5.7 comes into play. It is the step indicating the retraction of cylinder 1 for tool change. Once the cylinder retracts, the equipment can begin rotary movements and other tool changing actions. Next is M6.0, which represents reaching the fourth hole position. At this point, it may be necessary to move the x-axis or y-axis, while the stepper motor drives the turret to rotate to the proper position. M6.1 is the action step for extending cylinder 1 for changing and securing the tool. M6.2 indicates the execution of punching the fourth hole. M6.3 represents reaching the fifth hole position, and M6.4 corresponds to the step of punching the fifth hole. M6.5 indicates that the sixth hole position has been reached. M6.6 marks the execution of punching the sixth hole. M6.7 represents the retraction of cylinder 2 for the next tool change, preparing for upcoming tool changing actions. When the system reaches M7.0, it means that it has reached the 7th hold position. M7.1 represents the extension of cylinder 2 to fix the corresponding tool and position. M7.2 is the execution step for punching the 7th hole. M7.3 signals that the 8th hold position is reached. M7.4 is the step for punching the 8th hole. M7.5 represents reaching the 9th hold position. M7.6 corresponds to the final punching step, punching the 9th hole. M7.7 indicates the retraction of the punching cylinder after all holes are completed, which retracts the cylinder to prepare for subsequent work. Finally, M8.0 indicates that the entire punching process has ended, and the equipment begins the homing operation, returning the system to its initial state in preparation for the next punching task. In addition to these step-related bit memory units, there are several other auxiliary memory bits involved in the process. M10.0, start operation. M10.1, stop operation. M10.2, reset operation. M11.2, turret rotation completed. M12.4, X-axis movement completed. M9.4 and M9.5, different completion states of Y-axis movement. These bit memory units work together, following a predefined logical sequence step by step, to realize the full PLC program-controlled punching function on the training bench. That concludes today's lesson on the design of state diagrams and sequential function charts. After this lesson, you should now have a clear understanding of how to use the concepts of states and steps to build a complete PLC-controlled punching system. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.